In this example, we're going to find where f of x equals 3x to the fourth minus 4x cubed minus 12x squared plus 5 is increasing and where it is decreasing. And we're going to do this using our key idea, which is that we are going to find critical numbers and use the critical numbers to break up the number line. All right, to find critical numbers, we need to know where the derivative is equal to 0. So first we're going to find the derivative. And of course, if we were in class together, I would be asking you to tell me what the derivative is, and you would tell me it is 12x cubed minus 12x squared minus 24x. Because this is a polynomial, we know the only critical numbers we're going to get are where the derivative is equal to 0. We don't have to worry about it being undefined. So we're going to set this derivative equal to 0, and we are going to find the critical values from there. So when we set this equal to 0, of course what we want to do is factor so that we can find the places where this is 0. First thing, we're going to pull out the like terms. So we're going to get 12x, and we're going to get 12x times the quantity x squared minus x minus 2. And now we want to factor x squared minus x minus 2. And we're going to get 12x times the quantity x minus 2 times x plus 1 equals 0. So this means that our critical numbers are going to be x equals 0, x equal 2, and x equal negative 1. Now I don't have space to write all of this on one little board here, so I'm going to save that our critical numbers, critical values are x equal negative 1, x equals 0, and x equal 2. All right. And now I'm going to erase. So we have a little more space to work. Now what we're going to do is we're going to use those numbers to break up the number line. Now I'm going to label my number line with f prime below and f above, like so. And then I'm going to mark x equal negative 1, x equal 0, and x equal 2 on the number line. It doesn't matter if this is actually, proportionally correct. You just have to put the marks on there. Now, according to our key idea, the critical numbers break up the number line into segments where the derivative is either positive or negative, which will tell us whether the function is increasing or decreasing. And in order to figure out whether the derivative is positive or negative, all we do is we pick our value. They called it p in the key idea. We pick a number in this interval. I'm going to pick x equal negative 2. And here, I wish I had not erased the derivative, so I'm going to rewrite that so we have it to work with here. And our derivative in its factored form, which is what I care about right now, because it's the most convenient form to work with, is 12x times the quantity x minus 2 times x plus 1. So in this interval over here, less than negative 1, I'm picking x equal negative 2, just because it's a convenient value, but you could pick anything you want less than negative 1. And what we're going to do is we're going to take that and we're going to plug into the derivative. But I'm going to use this factored form because what we really care about is whether the derivative is positive or negative. We don't care about the actual value we get. And when we've got a product like this, it's really convenient for positive and negative because then we are looking just at multiplying the signs together. So 12x, when we plug in negative 2, that is going to be negative. X minus 2, when we plug in negative 2, is going to be negative. And then x plus 1, when we plug in negative 2, is going to be negative 2 plus 1 will still be negative 1, so that's negative. So we have a negative times a negative times a negative. So overall, the derivative in this segment is negative, which means that the function is decreasing. And I'm going to draw a little arrow just to remind us what that means. Now, in our next interval between negative 1 and 0, I'm going to choose x equal negative 1/2. And again, you can choose any value you want between negative 1 and 0. This one I think is convenient. We're going to plug into the derivative. So 12 times negative 1/2, that's going to give us a negative. When we plug in x equal negative 1/2 to x minus 2, we're going to get negative 1/2 minus 2. that will still be negative. When we plug in negative 1/2 to x plus 1, that's going to give us positive 1/2, so that will be positive. So we get negative times positive, so that overall that is positive in there. So that means the function is increasing because the derivative is positive. Next, we're going to go on to the interval between 0 and 2. For a convenient number here, I'm going to choose x equal 1. For x equal 1, what this is going to mean is that we're going to plug in to the derivative. So we're going to get 12x, so it's going to be 12 times 1. That will be positive. When we plug in x equal 1 to x minus 2, that's going to give us 1 minus 2, so that will be negative. And then when we plug into x plus 1, that will be 1 plus 1, which is positive. So we have positive times positive, which overall is negative. So that means the function is decreasing in that segment. Now we just have one more segment to go, and that's the segment where x is greater than 2. So we can choose any value we want bigger than 2. I'm going to choose 3 because it's close and convenient, easy to plug in. When we plug into the derivative, we're going to get positive from the 12x, that'll be 12 times 3 will be positive. X minus 2, 3 minus 2 will be positive. And then 3 plus 1 will also be positive. So we get positive times positive times positive. So overall that's positive. So in this segment, the function is increasing. So we're looking for the intervals where the function is increasing and where it's decreasing. So for our intervals, for increasing, that's between -1 and 0. And then also from 2 onward, so that's 2 to infinity. For decreasing, that is going to be from -infinity to -1, and then also from 0 to 2.